Hello, in this video we're going to be going over isotope notation. In the first part of the video I'll just talk generally about the format of isotope notation and the information that's included, and then I'll work through several examples after that. I'll have each of those parts time-stamped in the description below so you can click through to the part that you want to watch. At the center of our isotope notation will be the element symbol. This is the 1 or 2 letter symbol that comes from the periodic table. In our example here, I'm just going to use X as a placeholder. At the top left of our element symbol will be the mass number. Recall that the mass of an atom comes from the protons and the neutrons, and therefore the mass number will be our number of protons plus our number of neutrons in this atom. In the bottom left corner of our element symbol, we will have the atomic number. The atomic number refers to the number of protons in the nucleus of this atom, and the atomic number is also the number that the element is given on the periodic table. So if you look at a periodic table, the elements are listed from 1 to 118. That number is the atomic number for that atom. And the last bit of information that we will see in our isotope notation is the charge. And this will be in the top right corner of our element symbol. Recall that the 2 charged particles we have in atoms are protons with a positive charge and electrons with a negative charge. Therefore, the overall charge of the atom is dependent on the balance of protons and electrons. If there's no charge for an atom, that is to say if the atom's charge is neutral or 0, then you won't see a charge written in this position. So let's look at an example. Let's use isotope notation for this atom of cobalt to determine how many protons, neutrons, and electrons are in this atom. So first we'll start with the protons. You can see in our notation that we are given the atomic number of cobalt, which is 23. That is the number of protons in this atom. Once we know the number of protons, we can find the number of neutrons. Recall that the mass number, which is 63 in this case, is protons plus neutrons. So if we do the mass number, 63, minus the number of protons, 23, that will give us the number of neutrons. So 63 minus 23 is 40. We have 40 neutrons here. Now, most of the time, those numbers are pretty friendly, but you can use a calculator if you need to for that subtraction. Okay, last thing is the number of electrons. We can see in our isotope notation that there's no charge written. Again, the charge would be kind of in the top right, kind of that exponent position for our element symbol. And since there's no charge there, we'll assume that this charge is 0, that this is a neutral atom. And in that case, the number of protons will be equal to the number of electrons because they'll cancel each other out and there'll be no charge. So there we go. 23 protons, 40 neutrons, and 23 electrons for this atom of cobalt. All right, let's look at this next example. So in this example, we have an atom of phosphorus. And again, we want to figure out how many protons, neutrons, and electrons are in this atom. And if you look at this isotope notation, you'll see that I've done something kind of tricky. I've actually not given the atomic number or the number of protons for this atom. Now, occasionally we will do this, especially on quizzes and tests, because this is a good way to get you familiar with your periodic table. So in order to find the atomic number for this atom, we're going to need to go to our periodic table and we're going to need to find this element symbol. Okay, so I've pulled up my periodic table And I'm going on a little scavenger hunt, and I'm looking for the element symbol P for phosphorus. And phosphorus is actually over here on the right-hand side. There it is. And we can see that it is element number 15. That's its atomic number. So now that we know that information, we can go back and we can figure out how many neutrons and electrons are here. Okay, so according to my periodic table, there are 15 protons in this atom of phosphorus. That's its atomic number. So now we can figure out how many neutrons are here. We're going to do 32 minus 15. Again, the mass number minus the atomic number, which will be 17. And then for electrons, again, we can see we don't have a charge here. There's no charge written in our isotope notation. So that means that protons and electrons must be the same. So 15 electrons. In this example, again, we're going to find how many protons, neutrons, and electrons are present in this atom. But notice in this case, we have a charge. So we'll talk about how to handle that when we get to the number of electrons, but let's start with our protons and our neutrons. So for protons, we can see that we're given the atomic number for strontium, which is 38. That is our number of protons, 38. For neutrons, again, we're doing the mass number, 88, minus the atomic number, 38. 88 minus 38 is 50, so we have 50 neutrons in this atom. Recall that the charge is determined by the protons and the electrons. More specifically, charge is protons minus electrons. And in this case, since I'm looking for the number of electrons, I can take that little equation and rearrange it, setting it equal to electrons, and get electrons are equal to the number of protons minus the charge, which is the math that we'll do for this particular one. So my electrons are going to be my number of protons, so in this case 38, minus my charge of positive 2 or 2 plus, and 38 minus 2 is 36. So let's quickly talk about charges just conceptually, because I think they're probably the trickiest part of this isotope notation. So we'll have 3 types of charges. So positive, negative, and then neutral or no charges. So for positive charges, or cations, positively charged ions, this is a situation where you're going to have fewer electrons than protons. In other words, this is an atom that has lost electrons through some process. And so now it has more protons than electrons, which is where the positive charge comes from. We'll talk later on about why atoms want to lose electrons, or why that process would happen. And since protons and electrons all have charge of a magnitude of 1, right? So negative 1 for electrons or positive 1 for protons. If you see a charge of positive 2, like we did in the previous example, you can assume that it has lost 2 electrons, and so ultimately you're taking 2 away from the proton number. So we essentially did 38, which is the number of protons in strontium, minus 2, which was that cation's charge, and you get 36 electrons. Now, in the case that you have a negatively charged ion, or an anion, this is a situation where you're going to end up with more electrons than protons in that atom. So in other words, this is an atom that has gained electrons. And so again, since the magnitude of those charges, negative 1 and positive 1, is the same, you can essentially just add your charge to your proton number, and then that will give you however many electrons are present. And then lastly, we also have atoms that have no charge. This is a case where protons and electrons are equal. And so you don't have to do any sort of math or anything to figure out the number of electrons. If there's no charge, or if it's a neutral atom, protons and electrons are equal. All right, so we've done a few examples where we started with the isotope notation and then we went to protons, neutrons, and electrons. Let's do one in reverse. So in this situation, we're given the number of protons, neutrons, and electrons, and we're going to write the isotope notation for this atom. So first, let's figure out which element we're talking about. So we are given the number of protons here, which means that we can go to the periodic table, we can find element number 17, and then we'll figure out which element we're looking at. All right, so here's my periodic table. We have 17 protons for our atom, which means that we're looking at element number 17, which in this case is chlorine. So Cl is the element symbol for chlorine. So now that we have our element symbol, we can add in our atomic number there, 17. Next up, we'll do the mass number for the top left. So for that, we're going to do 17 plus 19, protons plus neutrons. 17 plus 19 is 36. So this chlorine has a mass of 36 AMU. And then lastly, we're going to look at the charge for the top right of our isotope notation. In this case, we can see that protons and electrons are not equal, which means that this is a charged atom. We can see that we have more electrons, 18, than protons, 17. So that means that this is going to be a negative charge. And because there is one more electron than protons, right, 18 electrons versus 17 protons, that means our charge is going to be -1. Now we can represent that as 1 minus, or if you prefer, you can also just write it as a minus sign without the number. That is also acceptable. And if you would prefer to do a little bit of math for that last bit, when we find the charge, remember that we said charge was the number of protons, 17, minus the number of electrons, 18 in this case. 17 minus 18 is -1, which is the charge that we have here for our chlorine anion. So there you have it. A little bit about isotope notation, a few examples. I hope that helps. If you have any questions, you know where to find me. Thanks for watching.